Okay, welcome to Getting Started with Project Sandstar. What we're going to do today is we're going to go through all of the steps necessary to get Sandstar code running on an embedded Linux device. The device we're going to be using today is the beaglebone, and the reason for that is if you go to the bitbucket.org Sandstar repository, you will see that there is a demo available that's already built for the beaglebone. Of course, Sandstar was made to be run on any embedded Linux device. We have a bunch of them here. We'll talk about that a little bit later. But first we'll get it running on the beaglebone. And that's probably the best way to get started with Sandstar, is get the code up and running on a device. So I'm going to turn off this beaglebone and we'll get started. Okay, so let's talk about what you're going to need to get started. Most importantly, you're going to need a beaglebone black. beaglebone black is an open source hardware as well as software development device. It's open source hardware, so it's actually manufactured by a bunch of different people. The prices range from $50 to $70 depending on which version you get. This version is the industrial rated version from Element 14, and of course it's not black, it's red. Most of them look like this. You're going to need an SD card with at least 4 gigabytes of capacity. If you have an SD card with more capacity than that, that's perfectly fine, and it's actually better for reliability purposes. And remember that all SD cards are not equal. Probably the best combination of reliability and price are the Samsung and also the SanDisk SD cards in the 16, 32, and 64 gigabyte capacities are the ones that are commonly available right now. You're going to need a PC. You're going to need an internet connection for the beaglebone. beaglebone black uses Ethernet, so you're going to need an Ethernet cable plugged into the internet. And then also, this is totally optional, but if you want to learn more about the beaglebone, I highly recommend this book, Exploring Beaglebone by Derek Malloy. It's a great book. It pretty much covers everything about this device that you would want to know when you're getting started. So the first thing we're going to do is load an operating system image on the beaglebone. Now the beaglebone actually ships with an image on the eMMC flash, which is right here, but we're not going to use that. We're going to put an image on our SD card, and when you have a valid image on the SD card and you plug it into the SD card slot in the back right here, it'll actually boot from the SD card image instead of the eMMC. Now, where to get this image, you can go to beagleboard.org, beagleboard.org latest images, and you'll see at the very top it'll say recommended Debian images. It's going to be the one that says 4 gigabytes SD IoT image. So download that one. It's going to be a zip file, and we'll talk about how to unzip and image the card next. Okay, so now that I've downloaded the image, I'm going to want to put it on this SD card. So I'm going to plug it into my adapter here, plug that into the PC. Now before I can image the card, I'm going to have to unzip the download. It's in a .exe format. You can unzip it using whatever extraction tool you prefer. If you don't know what to use, I'm using 7-zip. 7-zip is a free file management tool that you can download if you Google 7-zip. And then also to image the card, you're going to need a image writer. I'm using WinDisk Imager. If you look up WinDisk Imager, you can also download that for free. Now that we've written the image to the SD card, let's boot it up. Okay, so once this thing gets started, I'm going to SSH into it, and that stands for Secure Shell Connection. Um, what you're going to need is an SSH client. Uh, I'm using Putty, but if you have a preference for another software, you can use that. Putty's free to download. It's PUTTY, and it is an SSH client. So I just happen to know the IP address of this beaglebone, but you can also use the USB connection. If you're USB'd in, then it's going to be 192.168.7.2 because the beaglebone has its own IP network driver that it loads on your machine, so you can actually get IP connectivity to the device just plugging into the USB port. But then don't forget that it also is going to need that Ethernet connection, because you still need to be able to connect the thing to the internet to clone the Sandstar repository. So I'm going to start the connection. And the default login is Debian. And the password is temppwd. That's TEMPPWD. And that might change over time, so you have to check if this video gets kind of old. So there it is, we're in. Okay, so now that we have our beaglebone set up, the very first thing we're going to do is we're going to clone that entire Sandstar repository onto our beaglebone. So that's what we're going to need our internet connection for. Just keep in mind where you're installing the repository. Usually when you log in, you're going to be at home Debian. That's a good place to put it. Just keep in mind what directory location you're in, because the entire repository is going to get installed into that location. So to clone the repository, we're going to use get, and we're going to input the string sudo get clone https bitbucket.org and collabs sandstar.get. And what this is this is the URL of the repository, and it's going to basically take all of those directories for the project, and it's going to copy them onto your embedded beaglebone device. So let's go ahead and run that. It's going to ask me for my password because I typed sudo. So I'm going to type in TEMPPWD, and it's going to start cloning. We'll go ahead and let this run. Okay, so now that we've installed the entire repository, we've got lots of options and there's lots of things we can do, but this is going to be the quickest way here, what I'm going to show you to get the Sandstar code running on this device. So I'm going to navigate into the Sandstar folder by typing cd Sandstar, and then I'm going to list the contents. Now at the very top of the folder, at the bottom here, you're going to see a Debian package that you can install. So what we're going to do is we're going to type sudo and then dpkg and then install, and then we're going to install this package right here. And what you can do is you can just highlight it and then you just right click on there and it'll copy and paste that for you. So let's go ahead and run this. It's going to ask me for my password again. Okay, and now it's unpacking the Debian package, and it's going to install it. And what it's going to do is it's going to create a user EACIO. So we're going to go into that next. The package installer created a new user EACIO, but I'm not going to log out. I'm just going to go straight into EACIO's folder and run the Sedona virtual machine. So if you change directories to home, EACIO, and then Sandstar, and then bind, and then you list the contents, you'll see that you've got your Sedona virtual machine already built. And since this was built on a cross compiler for ARM for the beaglebone, all the libraries and everything and all the shared objects are already installed on this beaglebone, and we should just be able to run this thing. Let's go ahead and try that. So I'm gonna type if you're familiar with Sedona, you type svm, and then we'll run it in platform mode by typing -- plat. And there we go, we're up and running. Okay, so now not only is our Sedona virtual machine running, but also all of the Haystack servers and the Sandstar GPIO engine are also running. I'm going to go ahead and test out the Sedona part. I'm going to be using Contemporary Controls Sedona Application Editor. Contemporary Controls makes some really great stuff. They make rock solid switches and routers, as well as Sedona controllers. And they offer this application, the Sedona Application Editor, totally free. You can download it from Contemporary Controls. And if you have all of the kits and manifests in the appropriate folder after installing this software, you can connect to any Sedona device. So we're going to go ahead and test that out right now. I'm going to open a connection. The protocol, of course, is SOCKS. I've got my IP address of my beaglebone here, 192.168.1.95. Enter the IP address of your device. Of course, we're going to be using port 1876, which is the SOCKS port, and the username is admin, and there is no password. So let's go ahead and try to connect. And as you can see, I've connected to the device. I've already thrown down some components here before just to test it out, but it's just like any Sedona device, and you can, here's our hardware independent Sandstar kits. It's called the kit's called EACIO in this demo, but these are the kits that you will use to subscribe to the different channels, which are gonna talk to the Sandstar GPIO engine. So there it is right there. You've just assembled pretty much 90% of your first DDC controller.